So I've got this concrete beam. All I've done is taken off the measurements, and let's go through and draw it in. So let's change it to a layer of concrete. We've got concrete here, concrete 7, that will work. So I know my beam, I'm going to say it's a 3 meter span, so 3000. And I know it's negative 550 deep. So negative to bring it down from the top, because we're dealing with X and Y coordinates. So what have I got? Well, I've got a 30 millimeter cover. So let's offset in by 30. Let's bring the beam inside. And these are my boundaries, basically. So really the outside is concrete, my steel is confined in between. So let's draw a line. One from here to here to start off with. Now this line, what have I got? Well, I've got the thickness of my ligature or my stirrup, and then I have 2 N16s up top. So what we're drawing is how this beam looks from the side. Basically we're drawing in the steel cage that sits inside of it. It's the same principle for columns. So I allow, if I move this down by 10 millimeters, that's going to get me to the bottom of this ligature. If I move it down 26, I'm going to get down to the bottom of the bars, which is what I want. So let's move it down 26. And let's offset that back up by 16 for the diameter of the bars. So these lines through here is the bars, and our ligatures will run vertically up to this point. Looks like a lot of lines at the moment. It will make sense as we go. So same thing down the bottom, here to here. Let's move this one up by 10. So moving up by 10 gets me to this line here. Now I have 28 to get me to the top of the bars. So let's copy this one up by 28 millimeters. And there we go. So what I'm going to do is I'm going to draw a line from here straight down. This is where our ligatures are going to start. Now they don't start at the end here. They start a little bit in. They might start, 50 or 100 mil, probably not 100, maybe 75 mil in. So let's start this in by 50 to start off with, and I'll show you why at the end we might drag them all down a little bit. Offset by 10. So 10 mil is the thickness of the ligature. Now what I'm going to do is I'm going to draw a rectangle around it, just to make my life easier when we go to hatch it. So because I've now doubled up on lines, let's go through, select the ones. Remember, if we've got blue, selects everything covered, green selects everything it touches. So everything in the blue, and we just delete that one, just so I'm not doubling up. Now I can delete this outside line now. Don't need that anymore. Now these are going to be spaced at 300 centers. They might be more, they could be less. It's up to you as a designer. We design this for the shear capacity, so it all depends on the loads acting on the beams. So let's come through. We're going to space these, like I said, at 300. So hopefully I can remember my times tables. Everybody sits there and laughs at me. So here we are, 15, 1800, 700, 2400, 2700, and 3 meters. Cool. So the one here at 3 meters is sitting way far out of that beam, so I don't need that one. Delete. This gap here is probably a little bit too big. So what I might want to do is just select them all, and let's just move them down. Move them down by 75. So our spacings can be less than 300, they can't be greater. When you do your structural analysis, you'll read that in part of the code. part of the concrete code says that the spacing of these ligatures, it's a ratio. It's either 0.5 times the depth of the beam, 0.92 times the depth from the top to the center of the bars, or 300. So a lot of the time 300 is the governing factor. Alright, it's always the minimum of those three cases, but you'll learn that down the track. So for now, 300, and we're good to go. Alright, so trim. Now if I look at this beam from the side, basically what I've got here is the cage. I can't see through its ligature, it's solid steel, it sits around the outside of it. Alright, so what it does is these ligatures, or also stirrups, they help for numerous things. What I'm doing now is just trimming through them, so I'll just talk while I trim, so everybody's not bored. What they do is they increase the shear capacity of our beam. On top of that, they also help to confine and hold our longitudinal reinforcement. So this longitudinal reinforcement is quite slender, which means it's quite thin for how long it is. And part of that, it's a geometric failure or geometric property of the steel, is we have to confine it somehow. So these ligatures here effectively stop buckling occurring inside the concrete. That's probably all absolute gibberish, but what it's doing is it's holding it in place, so when anything squishes against it, it stops it from doing this. So there's numerous different reasons why we put it in there, but they're the main ones. Awesome, so that's my little ramble. We finished trimming through these. So what's next? Well, we've got our little, it kind of looks like a ladder. This is how our cage looks. If it was a column, basically you would just select it and rotate it up, and there's our concrete column. You have different ties, you'll tie them down in different ways, but it's the same principle. So like I said, you'll need to know how to draw this for your analysis subject when you come to designing concrete. So let's come through and just do some hatching. We're not going to annotate it. I've shown you how to annotate the front of the beam. You'll learn down the track how to do this one, but it's exactly the same principles as everything else. So hatching with steel, selecting objects. Alright, I'm not going to select them one by one, that's going to be really annoying. So let's do this, enter. That works. And now, well, I'm not going to attempt to use the hatch by internal point. Just going to draw a couple of rectangles in here, and then I'm going to select them, copy. You can go through and delete the lines if you just double it up on, but I'm just going to be lazy because it's pretty early in the morning. So let's go through and just copy these down. So 1, 2, this one, 1, 2, this one, 1, 2, so I have one more here. And I can delete that, it's too much. Come through again here. I have to do the same down the bottom. I can't copy or mirror because this is a different thickness in the bar. Alright, let's just copy these down now. Cool, and let's go one more here. Alright, let's come through again. Let's do a bit of hatching. Oh, sorry, hatch. Select the objects you want to hatch. Well, oh, that's really nice. Control Z. Let's try that again. Alright, let's do them one by one. So all I'm doing is just hatching in the steel components, and then we'll come through and we'll hatch in our concrete after. That's not very friendly. Control Z, it's going to let me do it all again. Sorry everybody. Let's do them one row at a time then, to hopefully prevent that occurring. So hatching is usually the most annoying part, or personally I find it the most annoying part of AutoCAD. Sometimes it's not the nicest to use. Let's come through and try it again. What I might do is just click enter here, because all of these now is one hatch. And now we'll try it on the last one. That way if it stuffs up, I don't have to redo it. Moment of truth, beautiful. So that's our steel all done. Let's go through now and let's hatch in our concrete. So hatch. Well, we do have concrete in here somewhere. So it's AR concrete. This is going to be, let's try 15, see how that looks. Pick an object, enter. Now what you find here is, well, it's floating in my steel, which I don't really want. So let's undo that. Now what's the easiest way to do this, as opposed to drawing polylines and everything else, which we might have to do, but let's go hatch, come back up, let's click down the arrow, internal point, we'll try to come from here, which is the most annoying way to do it, but let's try it anyway. Concrete 15, enter, click once, click twice, 3 times, still working for us, that's good. It's also very nice. Enter. Let's try again for the outside. Let's try down here first. There we go. Enter. So that's worked, and there's no crossing over at all. I know what you're thinking. This is very much so like those little pictures that you get, you know, a blank picture on a white bit of paper where you color in to the exact edges. Kind of reminds me of that. Anyway, this is how we do our reinforced concrete beams. This is the side view of it. Alright, completely hatched. So from here you can come through and do your annotations. So usually you would annotate this, and this would be your section from there. In this section you would then detail more of the spacings, any kind of lappings. So what I mean by that is, if this was continuous to another bit of concrete, I would have more bars coming up at an 800mm lap length. We'll go through this on Thursday when I see everybody, but effectively you have steel coming up and tying together as well. Those things here is what you would detail more so on a cross section like this, as well as any positive and negative reinforcement you have. Same principle for continuous beams or for single beams or for doubly reinforced beams, exactly the same way, and this is how you do it. So please make sure you understand how to do these drawings, and I'll see you all on Thursday with a lot more drawings to go through. Thanks guys.